welcome to my YouTube channel. So here today we are going to be looking at very interesting thing, which is forces against a leaning ladder. So at the end of this lesson we are going to be able to solve all these problems, which is going to equip you for any problem that you're going to encounter. If this is your first time watching the video, kindly like, subscribe and share for more, so that you are not able to miss this very effective content. So with that said, let's begin. So we are going to begin with this as our first question. So the first question says, a uniform ladder of length 6 meters and weight 300 newtons rests against a sloping vertical wall as shown in figure 4.3. The inclination angle between the ladder and the rough floor the rough floor is 37 degrees. Using your sketched free body diagram, determine the reaction forces from the floor, from the wall on the ladder, and the static friction coefficient at the interface of the ladder with the floor that prevents the ladder from slipping. So now, one thing that you need to know is this. So if we have this, let's say this is the floor. Let me take more space. So let's say this is the floor like that, then we have the wall like that, then let's say this is our wall there. So what is happening is we have a ladder like this. So now, depending on how strong the floor is, there is a chance that the ladder might enter into the wall. So let me demonstrate that. So let's say we have something like this, So if this part is very weak, let's say if the floor is very weak, we will find that this is what is going to happen. The ladder will enter the ground like that. Now, to prevent that, there should be a force. So that force is what we call the normal force. So the only reason why this ladder is not entering is that there is an upward force, which we are going to call the normal force like that. So this is the force that is preventing the ladder from entering. Now, at the same time, there is a chance that as it is leaning against the wall, there is a chance that this ladder might slip this direction as demonstrated here. So you will find that as there is force, let's say if someone is climbing, there is a chance that the ladder might slip this direction like this. So to prevent the ladder from falling like that, there should be a force. There should be a force that should prevent this type of effect. So that one, since the ladder wants to slip this direction, you will find that there should be a force that will be pushing the ladder like that, therefore making it to not slip. Now, this force is what we call the frictional force, because it is preventing the ladder from doing what's this, from going this direction, and frictional force opposes the motion, so frictional force will point in that direction. Therefore, we also have, if the ladder is uniform, we are going to have most of its weight will be concentrated at the center, which will be pushing down like that. So this will be the weight of the ladder. Then we also have this ladder also. If this wall is weak, this is what is going to happen. So if it is weak, you will find that the ladder can be able to break the wall and enter like that. This is what is going to happen. Now, the only reason why this is not happening is because there should be another force that will be pushing against that weight of the ladder, because the ladder is being applied, it's applying a force on the wall in this direction. So therefore, there should be another force that will be in the opposite direction. We are going to call this force as the force on the wall. So know this. This is what we are going to be using mostly. So for the other examples, I'll just say the normal force, the force on the wall, the frictional force like that. So now, with that said, so under this question, what you just need to start with is, first you need to look at your forces in the Y and the forces in the X as your first thing before you move on to talk. So we are going to have, so if you look at this, we are going to say first so we have the reaction forces. So the reaction forces we are talking about are the normal force, normal force, we have the frictional force, and the FW. So the only way you can find the values of these is by using the forces. You add the forces in the y first. So we are going to say summation of forces in the y should be equal to 0. Why 0? Because it is in static equilibrium. So static equilibrium simply means to say an object is not moving, and if it's not moving, the forces that are adding up in the y direction, that is going up and going down, they must add up to 0 so that it does not move. So that is a static equilibrium. So a body that is not moving like that, so that is static equilibrium. So the forces in the y should be equal to 0. So in this regard, what forces are those? So the one that is up, pointing up, is the normal force. So we are going to say the normal force, which is pointing up, then whatever is in the other direction shall be shall be subtracted. So this is going up, this is going down, so we are going to say minus the weight on the ladder should be equal to 0. So therefore the normal force should be equal to the weight of the ladder. That is how come it's not entering like that. Then the other thing that we are going to have is, so if we have that, do we have the weight of the ladder? So the weight of the ladder, we are told that it's 600 newtons. So we are going to say the normal force should be equal to 300 newtons like that. So with that said, that is the value of the normal force. Then we are going to go to our summation of forces in the x should also be equal to 0. So this is so we have the x direction, we have it is in the x direction. So we are going to say our Fs minus another force that is in the opposite direction is the force on the wall. So we have minus the weight should be equal to 0. So to make Fs the subject of the formula, we are going to say the frictional force should be equal to the weight on the wall, the force on the wall like that. But remember, from dynamics, the frictional force is equal to mu s times the normal force like that. So with this done, we are going now to replace. So we have our Fs is equal to our coefficient of static friction. We don't have it, so we can just keep this equation for now. We don't have it, but remember, we also have, remember that the frictional force is equal to the weight on the wall. So that means if we know the weight on the wall, we can use that to even find this coefficient of static friction as asked here, in which they are saying the static friction coefficient. Static friction coefficient means it is not moving. So this is as far as our forces can take us. So when you are done with your forces, you are now going to go with the torque. So we are going to say it's in static equilibrium. That means to say even the rotational motion, like the ladder, if it's like this, so the only reason why the ladder is not doing this is simply because the forces that are causing the ladder to more like spin in this direction and this other direction are equal. So that is torque, the turning effect of a force. So we are going to say the summation of the torque also, if you add all the torques, this should also be equal to 0. Now we are going, by convention, we are going to take the anti-clockwise to be positive and whatever is going this other direction to be negative like that. So the forces that are moving like that, then that simply means to say they are going to be oriented in that direction. So we are going to have now one thing that you need to know is that torque has got the formula, the force times the perpendicular distance. So the distance has to be perpendicular. Now I'm going to show you a very simple way of knowing the distance. That's where many fail the torque aspect. It is which distance are you going to get. So now with that said, so this was a free body diagram there. So with that said, we are going to see now how best we are going to look at our torque. Now we are going to take our pivot points to be the point at which this is more like touching the ground. So we are going to have something like this. So remember, the forces that are there are the forces on the wall. Then we have the frictional force, like that. Then we have the normal force at the pivot point, the normal force like that at the point of contact. Now, one thing that you need to know about, so the frictional force is at the point of contact as well. So one thing that you need to know about the torque is that whatever force is passing through the point of rotation, or rather the pivot point, does not produce any torque. So that is how it works. Okay, let's say that this is a door. So if you want to open a door, let's say this is the point at which the door is attached. Okay, let's say we have something like this. So let's say that this is the point at which the door is attached there. So there is no way for you to open the door using here. Let's say this is the doorknob. You will have to open here. So whatever force, even if someone was to push the door from the top here, it won't be able to open. The only person who can open the door is someone who applies the force this side. It will cause the door to open up, or someone who is able to pull the doorknob. They are able to open or close the door. But if you are applying the force here where the door is attached, there is nothing that will happen. The door won't be able to open. So this is the pivot point. So whatever force passes through the pivot point does not produce any torque, or rather the opening effect. So now with that said, we are going to look at the forces that are producing torque. So if this is the pivot point, the normal force produces no torque. Then we have the weight of the object. It is away from the pivot point, so it produces torque. So we have the weight of the ladder. Then we have the force on the wall. It also produces the torque. So we are going to have our summation of, we said our summation of our torque is equal to 0. So this torque, we are going to have something like, we remember it's force times the distance. So which forces are those? It is just this one and the weight. So we are going to have, let's begin with our weight. Now here you need to be careful. Okay, so let's say force times the distance. So remember, this force is trying to cause the ladder to go this direction. So remember, anti-clockwise produces positive, clockwise produces a negative, like that. So we are going to have force times the distance. Then we are going to have minus, since this other force wants to cause the ladder to go in the other direction. So it's pushing like that, meaning it's like this. So it will produce a negative, which is that one. So the force on the wall, we must be specific, times the distance minus the weight of the ladder times the distance, like that. Now I need a way to differentiate this. This distance and this distance. So mostly we don't even write this, but it was just for the sake of your understanding. So we can say the distance of the ladder, like that. This is the distance of the wall, should be equal to 0, like that. Now this is where many get confused. Which distance are you going to use? So let's look at the wall like that. So if you're looking at the wall like that, we are going to have something like this. Which will be, so the wall is producing the force there. So what you're going to do, the pivot point is here. So the wall, you are going to go where it is in contact with the wall. This force, you're going to extend the force like that. So you're going to extend the force like that. Then this same force, if you have an extended force there, you're going to draw another line from the pivot point, which is the point at which there is contact, which is parallel to this extended thing. So as you get used, you are going to just be going direct with these things. So now, as you get used, you're going to go direct. You draw two parallel lines, so you extend this line and this line. Then the distance between them, so the distance is from here up to here. So this distance, which is the same as here up to here. So this distance is the distance you're going to consider as the distance of the torque. Now remember, if the angle is here, if we have the angle theta, in this case it's 37, the opposite side, remember your knowledge of vectors, your opposite side shall attract the sine of your angle 37 degrees with the height. Now the hypotenuse is 6, so this side it will be 6, then you're just going to say 6 sine of 37, like that. So that is how we are going to be doing these things. So we are going to say the force on the wall, we don't know the force on the wall. Remember, we tried it, but we didn't know. So we are going to say the force on the wall times the distance. So we are going to get the distance from the point, from the pivot to the where it is being applied, which is our 6 there. So we are going to have our 6, then we are going to attach the sine of our 37 degrees, like that. Then we are going to say minus, we have the weight of the ladder. So the weight of the ladder is 300 newtons. So we are going to say 300 newtons times our here you need to be careful. So if they have said that the ladder is uniform, that means to say its weight is concentrated at the center. So that's the distance you are going to take. So half of 6 is 3. So from here up to here, it will be 3 meters, like that. So you are going to go at the 3 meter mark, like that. Then you are going to have something like that. So the weight of the ladder is, the force is applying downwards, like that. So you are going to extend this weight, so like that. So this is what is going on, like that. So for the sake of understanding, let me just draw it straight. So we have something like this. So now what you are going to do is that, since there is it is going down like that, go at your pivot point, draw a line that is parallel to this line, which will be this. So these two lines are parallel. Then look at the separating distance. It is this one. So since the separating distance is that, we are going to get the angle 37 is here, and as long as the angle is in contact, we are going to associate it with sine. So remember, the distance from the point where it is applying the force is 3 meters. So this distance will be equal to 3. So you always take the distance. We took 6 because it was from here, the force was being applied at the end. So we are going to have 3. Then we are going to say cos of 37 degrees. Why cos? Because the angle is in contact. So as you get used, it will just be direct, like that. So with that said, we are going to have times our 3 cos of our 37 degrees should be equal to 0, like that. Then all we have to do is multiply. So we have our 6 sine of 37. This will give us a value of, so we have our FW times our 3.61. Then we have minus our 300 times 3 cos of 37. This is going to give us a value of 718.77, should be equal to 0. So this will give us our FW times our 3.61. Let me just move this. Should be equal to, if this goes the other side, it will be 718.77, like that. So we have divided by 3.61 divided by 3.61. We are going to have our FW should be equal to, when we divide, so divided by 3.61, this is going to give us a 199.12, like that. So this is our force, the Newton force, like that. So we have found the normal the force on the wall, like that. So we are required to find the reaction forces. That means to say the frictional force, the normal force, and the coefficient. So remember, we have said that the force on the wall is equal to the frictional force, which is equal to 199.12 newtons, like that. Then what we are going to have is, we know now, we said Fs is equal to mu s times the normal force, like that. We are just going to replace our Fs is equal to 199.12 should be equal to our mu s, we don't know, times the normal force. Remember, the normal force we found it to be 300 newtons. So we are going to take that 300 newtons times 300 newtons, that over 300 newtons over 300 newtons, like that. So our coefficient is equal to, so we divide by 300, we are going to have a 0.664, like that. So this is the coefficient. So to sum up, we have our Fs is equal to 199.12. We have it's a force, so our force on the wall is also 199.12 newtons, and the mu s is equal to 0.664, like that, without the units. So it should be less than 1. Yeah, so that is the coefficient of static friction. So these others, we're just going to walk over them since we now know. Let's move on. For those of you that want the full access to the video, you can just inbox the number 07645 999 15 if you want all the access to the video. So now, looking at this other one, it says that states the conditions for the system to be in static equilibrium. We have already talked about this. So you can just say the net force, this is the summary, net force should be equal to 0. So that is the first condition. Then we also have the net torque. The net torque should also be equal to 0. So net simply means the addition. So the sum, if you want, you can say the sum of the forces should be equal to 0. The sum of the torque should be equal to 0. Now, with this other one, we are told that a 5-meter uniform ladder, meaning to say its weight is concentrated at the center of weight 150 newtons, stands against a wall at an angle of 37 degrees above the horizontal, as shown in figure 4.2. There is no friction between the ladder and the wall, but the coefficient of static friction between the ladder and the floor is 0.5. An electrician is weighing 700 newtons, slowly climbs the ladder to fix a light bulb. He then senses that the ladder is at the verge of slipping and stops at position X, m meters from the base of the ladder. Determine the value of X measured from the base of the ladder. So we want to know this distance. What is the value of this distance? So to do that, we are going to look at the same thing that we were doing. So we have let's begin with our free body diagram. So we have our force on the wall, remember, so the force on the wall, then we have, it wants to slip this direction, so there should be a resistive force, which is the frictional force. Then we also have the force pulling up, like that, so we have the force there, which is our normal force, like that. Then at the center, we are going to have the force of the ladder, the weight of the ladder, like that. Then we don't know where the person will be, but they will be exerting a downward force, so the weight of the person, or rather the electrician, will be at that point. It can be before the half, but we don't know, but we are just assuming. This is just for the sake of making the problem to be simple. So with that said, we are going to begin with our forces in the y should be equal to 0. So what do we want? We want to know how far it can go up, but the only way you can get distance is using torque, but we can't go direct. Let's first deal with the forces in the y, because we will need them. So the forces in the y, So the one that is pushing up is the normal force. So we are going to say the normal force minus, so that is the normal force minus the weight of the ladder it is pushing down, minus the weight of the electrician should be equal to, we have a 0 like that. So the normal force should be equal to the weight of the ladder if it goes the other side, this goes the other side, then we have plus the weight of the electrician like that. So the normal force should be equal to what is our weight of the ladder. So the weight of the ladder according to the question is 150 newtons. So we are going to have our 150 newtons. We are going to add it with the weight of the electrician. According to the question we are given, it is 700 newtons like that. So if we add these two, we are going to have our 850 newtons like that. So with that said, we are going now to move on to our forces in the y or in the x. So the forces in the x we are going to have, so let's have our forces in the x should also be equal to 0. So this is going to give us a value. So which forces are those? So we have the frictional force. If you want whatever you can begin with this or this. So we have, let's begin with force on the wall. It is this direction. Then the frictional force is this other direction. So we are going to say minus the frictional force should be equal to 0. They are moving in opposite direction. So the force on the wall should be equal to, this goes the other side. We are going to have this value. Now, remember our Fs is equal to our coefficient of static friction times the normal force like that. So our mu s should be equal to, we have what is our mu s value? We have been given that it's 0.5. So we are going to have our 0.5 times the normal force, which we have found to be 850. Then when we multiply this, we are going to have 0.5 times 850. This will give us a 425 newtons like that. So this will be our frictional force. But remember, we have said that the frictional force is equal to the weight on the wall, which should be equal to the 425 we have found. Now to find the distance, we are going to go to torques. So the summation of torques should be equal to 0. So what do we have? So remember, we have this. So this is what we have. Then what we are going to do is, we have the weight on the wall, we have the weight of the ladder, we have the weight of the electrician. Let's say if they are head like that. So we have the weight of the electrician. So these are the only, the frictional force will not produce any torque because it's passing through the pivot point. The normal force will also not be able to produce any torque since both of them are passing through the pivot point or the point of contact there. So now, with that said, we are going to begin with our wall there. So now, looking at where the wall is, we are going to have, let me just use this same diagram. So force on the wall there, we extend the force like that. We also extend the force like that. So by extending like that, then the distance we are going to get is the height difference like that. So this is the height we are going to get. Now if the angle is here, that means to say the opposite will be your sine like that. Now which angle are we provided with? So the angle is 37 degrees. We have rotated the diagram, but anyways, it doesn't matter. So we are going to have, okay, let's just draw the way it is, the diagram the way it is, but it will still give you the correct answer. So we have this, yeah, so we extend. Now this one will produce the clockwise torque, the clockwise torque, which will be considered to be negative. So what we are going to do is, let's begin with the ones that are positive. So we have the weight of the electrician, which is pushing down, and the weight of the ladder. Since we dealt with the ladder, let's begin with the ladder. So we have something like this. Then the ladder is here. So it is pulling down like that. So it is going down like that. So that's the weight of the ladder. It's pushing down like that. So it's continuing like that. Then we are going to go at our pivot points like that. We are going to extend, draw a parallel line like that. So this parallel line, we are drawing the parallel line like that. Then the distance we are going to get is the difference between the two. So just as we have seen, so we have this and we also have this. So these are our two parallel lines. Then the distance is just here. So this is the distance. So what we are going to do is that we are going to use cos, since that's the base of the angle. So we are going to have the weight of the ladder. Remember, torque is force times distance times the distance. Now half of 5 is a 2.5. So if you want, you can write 5 over 2 here. Yeah, if you want, you can just go direct. We have 2.5 like that. Then 2.5 times the distance. The distance is 2.5 times the cos of the angle 37 degrees. We have plus another one, which is our electrician who is here. Let's say, imagine they are here, but this distance we are going to call it x. We don't know, so it is x. So they are exerting a force downwards like that. Since they are exerting a force downwards like that, we are going to say plus our weight of the electrician times the distance from here to where the electrician is. We don't know, so we have called it x. Then we have times the cos. Still we are going to use cos. Why cos? Because if you draw these two parallel lines, let me remove this parallel line. So these two parallel lines are looking like that. Now from these two parallel lines, the separating distance is this one. So, and the 37 is touching this line, so we are going to use cos. So we have the cos of 37 degrees like that. Then we are going to say minus the wall. On the wall we have the wall there. So this wall wants to cause the clockwise, so it will be negative, so that's why minus there. Then we have the force on the wall times the distance. So remember, the angle is here 37 degrees, parallel axis 37 degrees. We are going to go at this point. We extend this one. We also extend, since we are going to extend this side like that. So we have something like this. So it's continuing like that. So then the separating distance is the from here up to here. So this is what we have as our separating distance. So since the angle is here, it shall attract the sine. So the opposite has to do with the sine. So what is the distance from here up to here? It is 5. So we are going to say this distance is 5 sine of 37 degrees. So we are going to say times the distance, which is 5 sine of 37 degrees, should be equal to 0 like that. So let's now plug in the value. So the weight of the ladder is 150. So we are going to say 150 times 2.5, the cos of 37 degrees, plus the weight of the electrician, which is 700 newtons, times the x, be careful, times the x cos of 37 degrees, minus the weight on the wall. We have found it to be 425, the weight on the wall. So remember, we have found it to be 425. So we are going to say 425 times 5 sine of 37 degrees like that. So let's press. So we have our 150 times 2.5 cos of 37. This is going to be 299.49. Then here, if you press 700 cos of 37, you have 700 cos of 37. This is going to give us 599, so we have plus 559, sorry, 559.04. But remember, there is x. It's okay, you can multiply 700 times the cos of 37, but even if this is there, but don't forget about it. So we have x there, then we have minus 425 times the 5 sine of 37. This is going to give us 1000. So we have 1278.9, like that should be equal to 0. So we are going now to so the like terms that we have here are this one and this one. So we are going to add them, or rather subtract them. So our this, when we subtract, we are going to get a value of, so we have, first we have this value which is untouched. We have 559.04 x. This and this, we are going to have negative 979.4 should be equal to 0, like that. So we take this the other side. This is going to give us, so we have our 559.04 x should be equal to 979.4, like that. We divide our 559.04, we divide our 559.04. so when we divide that, we are going to get a 559.04. this is going to give us 1.752 meters. Sorry, some people are making noise. So that is so this is the amount of distance that the electrician can cover without the ladder slipping. So this is the maximum height. So if he exceeds this distance, the ladder will be able to slip and it will be able to fall, as I illustrated. So that's how we find the distance. Let's look at a similar question. Looking at this one, we have a 600 Newton. We have a 6-meter uniform ladder of weight 200 stands against the wall at an angle of 53 degrees above the horizontal. There is no friction between the ladder and the wall, but the coefficient of static friction between the ladder and the floor is 0.55. An electrician weighing 600 newtons slowly climbs and the ladder to fix the light bulb. What is the maximum distance he can climb, measured up the ladder from the base before the ladder falls? So this one is just the same problem. So we have this type of a situation. So we have the electrician is moving, but I've just solved it so that you can be more and more conversant like that. So now what we are going to have is, we have the force on the wall like that. Remember, we have the force on the wall, we have the normal force, we have the normal force like that. We have its uniform, meaning to say its weight is concentrated at the center. So we have the weight of the ladder. Then we have the weight of the so this is the electrician still. So the weight of the electrician we have like that. So we have the frictional force like that. So all we have to do is, let's begin. Our summation of forces in the y direction is equal to 0. Which force? We have the normal force. So we say normal force minus, we have the ones that are down are the weight of the ladder minus the weight of the electrician, should be equal to 0, like that. So we are going to get something like, if this goes the other side and this goes the other side, so the weight of the normal force will be equal to the weight of the ladder plus the weight of the electrician, like that. So with that said, we are going to find the weight. So we have the 200 and we also have the 600 for the electrician. So we are going to have 200 newtons plus the 600 newtons for the electrician. So the normal force will be equal to 800 newtons. With that, let's deal with the forces in the X. So we have the summation of forces in the X should be equal to 0, like that. So we are going to have the normal force, the frictional force, and the weight on the wall. So we are going to say the weight on the wall minus the frictional force should be equal to 0. So we have this should be equal to Fs, like that. Remember, Fs is equal to mu s times the normal force, like that. So our mu s is equal to, we have a 0.55 times the normal force, which is our 800. So we are going to have that. So when we do that, we are going to get a value that is equivalent to, so 0.55 times 800. This is going to give us a 440. So we are going to have a 440 newtons, like that. So we have our Fs, we have our Fs. Now remember, we have said our Fs is equal to the weight, the force on the wall should be equal to 440 newtons, like that. 440 newtons, like that. So after dealing with that, now to find the distance, you go for torques. Now the summation of the torques should be equal to 0. So looking at this situation, we have something like that. So let's begin with the clockwise. In this case, it is the force on the wall. So as long as you're consistent, the answer will always come out to be correct. So we are going to extend this force, go at your pivot, extend this point, and look at the difference in the distance. So this is the difference in the distance. If that is the case, then that simply means to say you are going to say, since it's here, if the angle here is 53 degrees, is it? So we have the angle of inclination, which is our 53 degrees. So we are going to put our 53 degrees. So the opposite will be the sine. So we are going to have our distance. If this is 6 meters, at the point of contact from here to here, it's 6. So we are going to say 6 sine of 53 degrees. That's the distance. So we are going to begin with that and say the force on the wall times the distance, which is our 6 sine of 53 degrees. Then we also have, we are going to go, this is the only one that is pushing like that. Then we are going to say minus which other force. So the weight of the ladder, so if we have something like this, we have the weight of the ladder. So from here up to here, the weight of the ladder is 3 meters there. So we are going to have the weight of the ladder times the distance is 3 meters. Since it's a uniform thing, it means to say its weight is concentrated at the center, and half of 6 is 3. So we have 3. Then we are going to have sine or cos. So let's go back. So looking at this point of contact, if we extend here, that means to say we have to extend. So the distance, the separating distance is this. So the separating distance is this. This is our separating distance, and if it is in contact with the angle, that means to say we are going to say cos. So we are going to say the cos of 53 degrees, like that. 53 degrees. Then we have minus again the weight of the electrician. So we don't know where the electrician is. Let's say they are here, down. We extend, go at your pivot points, draw another parallel line. The separating distance between the two is what we call the distance we are going to consider, and since it's in contact, we shall assume the cos. So minus the weight of the electrician times distance we don't know, let's call it x, times the cos of our 53 degrees. Remember, you're going to use cos because of that rule. So with this rule, as you get used, there will be no need for you to draw this. Should be equal to 0. So with that said, let's now work out. So FW, do we have FW? So we have FW is 440. So we are going to write our 440 times the 6 sine of 53 degrees minus the weight of the ladder is 200 newtons. Then we have times the 3 cos of our 53 degrees. Then we have minus the weight of the electrician is 600 newtons times the x cos of 53 should be equal to 0 there. So there is an equal 0 there. So we are going to now calculate our 440. Then we have times the 6 sine of 53. This is going to give us a value that is equal to 2108.4 like that. Then we have minus, we have 200 times the 3 cosine of 53. This is going to give us a 361.1 like that. Then we have minus, so if you press your 600 cos of 53, it will be 600 cos of 63. It will still give you a 361.1, but we have x here, so you are going to put x should be equal to 0 like that. Let's take this value this side. So we are going to have 2108 minus 361.1. We are going to have 2108.4 minus 361.1. This is going to give us a value of 1747.3. Should be equal to, we take it the other side, it will be 361.1 like that. We divide, we are going to get our x should be equal to, so divided by 361.1, we are going to have our x is equal to 4.84 meters. So that is how we solve that question. Let's move on to our next question. So we have a ladder whose length is 12 meters, whose mass is 45 kg, rests against a smooth vertical wall on a rough horizontal ground. Its upper end is a distance of 9.3 above the ground. The center of gravity of the ladder is 1/3. Now they have given us the center of gravity is 1/3. 1/3 is here of the way up the ladder. Of the way up the ladder, a firefighter whose mass is 72 kg can climb 85% of the way up the ladder before it starts to slip. Calculate the coefficient of static friction between the ladder and the ground. So to answer this one, it's a bit involving, but let's get through it. So let's begin with converting our masses to weight, because we are going to be dealing with weight. So the mass of the ladder is equal to, we have 45 kg. Then we also have the mass of the firefighter is equal to, we have 72 kg like that. So now let's convert this. So we know that weight is equal to the mass times the gravity, so which will be our mass 45 kg times the gravity, which is our 9.8 newtons per kg. When we multiply this, we are going to have 45 times 9.8. This is going to give us a 441 newtons like that. Then the mass or the weight of the electrician will also be equal to the mass 72 kg times the gravity 9.8 newtons per kg. So that's per kg there. So our weight should be equal to, we have 72 times 9.8. This is going to give us a 705.6 newtons like that. So if that's the case, we have 705.6 newtons like that. Then we are going to get our, so these are our values there. So let's now look at what we are going to get. Let's look at this. So it is a ladder whose length is 12 meters. So according to what we have been provided, it is a ladder that is 12 meters like that. So if that's the case, we have 12 meters of the ladder, then we are told that, let me move this so that we don't have to move a lot. Okay, so we are told that it is 12 meters whose mass is 45, rests against a smooth vertical wall on a rough horizontal ground. Its let's just extend. Its upper end is a distance of 9.3. So upper end 9.3 meters above the ground. So from here, upper end from here to here, we are told that it's 9.3 meters. Then what other information do we have? We know that it is 12 meters from here up to here. That is what we are told, that the ladder. So this is our ladder there. So that's our ladder there. The yellow one is our ladder there. So now, with that said, we have the 9 meters there. What other information do we have? We are told that the center of gravity of the ladder is 1/3 of the way up the ladder. 1/3 means 1/3. The ladder is 12. So we want to see where the mass is mostly concentrated. So 1/3 times 12 will give us a value of 4. So we are going to have, so the weight of the ladder is concentrated at the 4 meters, like that. So we have the 4 meters from here up to here to the center of gravity. We have 4 meters. So that means to say this is where the mass will mostly be acting. This is important. Then the other thing that we have is we are told that a firefighter whose mass is 72 can climb 85% of the way up the ladder before it starts to slip. Remember, it can climb 85%. So that means to say, what is 85%? What is 85% over 12? That is the question. So that is how far they can climb. So we know that a percentage is always out of 100%. Then we are going to multiply the 12. Why multiply by 12? Because 12 is the maximum. What is 85% of 12? You will find that it's even smaller than 12. So we are going to have our 85 divided by 100. It will give us 0.85 times our 12. This will give us a value of a 10.2. So we are going to have 10.2 like that. So if we have our 10.2, that means to say this man can only climb as far as 10.2 meters, like that. So he can climb 10.2. So at above this point, so this is the point at which the ladder is at the verge of collapsing. Then what other information do we have? Have we been given the angle? But we need the angle. So let's find the angle. So if you know to say we have the whole ladder is 12 meters. We know to say to find the angle, we have the opposite and we have the hypotenuse. Hypotenuse, which is the total length of the ladder. We are going to use sine because we know the sine of theta is equal to opposite over hypotenuse. So that's our sine. Let's move this a bit. So we are going to have our sine of theta should be equal to our opposite, which is equivalent to 9.3. So opposite to this angle is 9.3 over the hypotenuse, which is our 12. So if we divide, we are going to have our 9.3 divided by 12. We are going to have 0.77. Okay, let's just move this the other side. So our theta will be equal to sine inverse of our 9.3 over our 12, like that. So this is going to give us, so the sine inverse of our 9.3 divided by 12, this will give us an angle of 50.8 degrees, like that. So this is our value of our theta, like that. So if that's the case, we can now, let's deal with the summation of forces in the X. So the summation of, the weight of the ladder, remember what we found, the weight of the ladder was 441, was it 441? So the weight of the ladder is 441, the weight of the electrician or the firefighter is equal to, we found it to be 705.5 0.6 newtons. So this is what we have. So if that's the case, we are going now to say the summation of forces in the y should be equal to 0. So we have let's just do everything here. So we have the force, the frictional force this side, then the upward force is the normal force. So we are going to say the normal force minus the weight of the ladder minus the weight of the firefighter should be equal to 0. Remember, those are acting down while the normal force is acting up. So we are going to have the normal force should be equal to, we take all these the other side, it will be the weight of the ladder plus the weight of the firefighter. So the normal force should be equal to, we have our 441 for the weight of the ladder plus our weight of the firefighter is 705.6 newtons. This is going to give us, so we have our 441 plus we have our 705.6. This is going to give us a value of 1146.6 newtons, like that. So we have the normal force like that. So if that's the case, we are going to have so this is what we have. Then we go to our summation of forces in the x should also be equal to 0. Which forces are those? So we have the force on the wall, remember, force on the wall. So we have FW for force on the wall. So we are going to have the force on the wall minus the frictional force is equal to 0. We take the frictional force the other side, we have this should be equal to like that. With that said, we are going to have our F S, remember it is equal to mu S times the normal force, like that. So this is going to give us the coefficient of static friction is, so according to this we are told to calculate the coefficient of static friction. Now remember Fs is equal to this, but this is also the force on the wall, so we just need to find the force on the wall, and whatever value we will find, it will be the frictional force, and we can now finally find it there. So what we are going to do is we are going to calculate. Now we are going to go to our torque, since our forces cannot help us. So the summation of forces of the torque should be equal to 0. So let's look at the conditions. So we have the ladder like that. Then from the ladder there we have the force on the wall. So we are going to have the force on the wall times the distance. So it is 12 meters. Remember, from the pivot point to the point of application it's 12 meters. So we are going to have 12. Remember that we have found that this angle is 50.8 degrees. So this opposite side, you can say this opposite side, it will be 12 sine over our 50.08 degrees. Now if you press your 12 times the 12 sine of 50.8, this is going to give you a 9.3, which is the angle which is the distance that they actually gave us. So we have 9.3. So if you want, you can say 12 sine of 50.8, or you can just go direct. That is if you know the distance, because that is an indirect way of finding the distance. So remember what we were doing. So we have a 9.3. If you do it like that, it will still be the same. So we have just an emphasis. You draw a parallel line, you draw another parallel line, the opposite side, the height there is your distance you want, so parallel, then the remaining is the separating distance, so 9.8. Then we have minus, we have the electrician can go as far as, remember we have been told that it can go 85%, and we found 85% of 12 meters to be 10.2. So we are going to extend his force like that, extend another force like that, then look at the separating distance. So this is our separating distance like that. So we are going to have the weight of the electrician or weight of the firefighter times our 10.2, because that's the distance he has traveled, times the cos. Remember, it's a cos because the angle is in contact. Cos of 50.8 degrees. Then, so remember, the distance that we are actually looking at is this. So if you already knew this, you can just write it direct. Then we have our minus the weight. Whose weight again? We have the weight of the ladder. So we have the weight of the ladder. Let me just do this. The weight of the ladder from here, it is 4 meters there. So we were told it's 1/3, so 4 meters. So from here up to here, it's 4 meters. So we are going to say the weight of the ladder times the distance where it's concentrated, it is 4. Then we are going to attach the cos of our 50.8. 50.8 like that should be equal to 0. So that is what we generally have. That is what we generally have. So we are going to have our value, which will be our, let's now press our force on the wall. We don't know it, so we have the force on the wall times our 9.3 times the weight of the electrician. We have our 705.6 times the 10.2 cos of our 50.8. Then we have minus the weight of the ladder, which is our weight of the ladder. We found it to be 441 times 4 cos of our 50.8 should be equal to 0 like that. We are going to have our 9.3 FW. Then we have minus. So when we multiply this, we are going to get a value of 705.6 times 10.2 times the cos of 50 times the cos of 50.8. This is going to give us a value that is equivalent to 4,548.79 like that. Then this value minus, if you press here, if you press 441 times our 4 cos of our angle 50.8, we are going to get a value 441 times 4 cos of 50.8. It's giving us a value of 1,114 point. We have our 9 like that. This should be equal to 0. So we are going to have our 9.3 FW. So we are going to have our 4,548.79 plus, or rather minus our 11149.9 there. We are going to have our minus 5663.69, which should be equal to 0. So we have 9.3. 9.3 should be equal to this, because the other side it will be our 5663.69 like that. We have our FW 9.3 over 9.3. So our FW will be equal to, when we divide our 9.3, 5,663.69 divided by our 9.3. This is going to give us a value of 608.999 like that. So this is our FW. So this is our FW. Remember, we said that FW is equal to Fs, which should now be equal to 608.999 newtons. So we know that Fs is equal to mu s times the normal force. So our Fs is 608.999 should be equal to, we have should be equal to mu s times the normal force. Remember, the normal force is equivalent to, we found it to be equal to 1114, should be 1146 1146.6 1146.6, which should be equal to, just like this. So we are going to divide, since we want to leave mu s alone. So we are going to divide like that, for 6.6. So we have something like mu s should be equal to, so when we divide, we are going to have a value that is equivalent to, we have a 0.531. So this is our coefficient of static friction, like that. Our final question. So we have a ladder is made to lean against a smooth wall, forming an angle of cos theta is equal to this with the wall. If the ladder has a mass of 1/5 the mass of the man, meaning to say it is 1/5 times the mass of the man, so that's the weight or the mass of the ladder. So the mass of the ladder should be equal to this. Then we are told that calculate how high up the ladder the man can safely climb if the coefficient of static friction between the ladder and the floor is tan 20 degrees. So the first thing that we are told is, let's analyze it. So we have the ladder, it's leaning against the wall like that. So this is our ladder here, it's leaning against a wall. Now we are told that forming an angle of cos theta degrees is equal to this with the wall, with the vertical wall. So meaning to say the angle, which is our cos of cos theta, is equal to 0.643 should be equal to that. So we are going to find our angle here, which is our theta should be equal to cos inverse of our 0.643, like that. So our theta should be equal to, we have our cos inverse of our 0.643. This is going to give us our angle of 49.98 newtons. So this is our angle here, which is our 49.98. So the wall is made straight, so meaning to say the angle here is 90 degrees. So we are going to assume that the wall is straight like that. But for these calculations, you can use this angle, but I don't use this angle. So we are going to use this angle to make the problem very simple to use. So we are going to have to find this angle. We know that already this is a triangle, so we have this plus this will add up to 180. So we are going to have let's say this is our x, so x plus our 49.98 degrees plus our 90 degrees here, 90 degrees should be equal to 0. So we have our x plus, we have our 49.98 plus our 90. We are going to have our 139.98 should be equal to 0, not 0, sorry. Angles in a triangle will add up to 180 degrees. So this should be equal to 180 degrees. So our x value will be equal to 180 degrees minus this value, which is 139.98 degrees. This will be equal to, minus our 180, this will be equal to 40.02 degrees. So that means to say the angle here is 40 degrees. So we have found that much. Let's now deal with the other remaining parts. We are also told that calculate how high up the man can safely climb if the static friction between the ladder and the floor is the tan of 20. So the tan of 20, we are just tan of 20, that's the coefficient of static friction. So the tan of 20 is equal to our 0.364, like that. So this will be our mu s, like that. If that's the case, what we are going now to do is, let's now deal with, so we are told to calculate how high up what else do we have? If the ladder is 1/5, the ladder leans against this. Have we been told anything how high up? So if we haven't been told anything about whether it's concentrated at the center or not, we are going to assume that the ladder is uniform, meaning to say its mass is concentrated at the center. So with that said, let's now be able to deal with the summation of forces in the y direction is equal to 0. So remember, we have the ladder there, so we have the weight of the ladder at the center and the weight of the man there. So we have the weight of the, or what's the man's position. So if the ladder, the man, so let's just call it the weight of the man, the weight of the ladder, like that. So we are going to have then remember, we have the upward force, which is the normal force. Then we have the frictional force, like that. So we are going to get something that is equivalent to, we have the normal force minus the weight of the man minus the weight of the ladder should be equal to 0. So we are going to have the Fn should be equal to the weight of the man plus the weight of the ladder, like that. So our Fn should be equal to the weight of the man, which is equivalent to, the weight of the man is equivalent to 70 kg. Let's just convert this. So the weight of the man, we could have done this calculation. So the weight of the man is equal to 70 kg times the 9.8 newtons per kg. This will give us 70 times 9.8. This will give us a value of 686 newtons, like that. So this is the weight of the ladder. Then also the weight of the man should be equal to the weight of the man, sorry, this was the weight of the man. Then the weight of the ladder is 1/2 times the 70 kg, which will give us something that is equivalent to 1 divided by 5 times our 70. This is going to give us 14. So we have 14 kg. So the weight will be equal to 14 kg times 9.8 newtons per kg. This is going to give us a value that is equivalent to 137.2 newtons. So this is the weight of the ladder. So that's the weight of the ladder. So therefore, remember, we are saying that the normal force is equivalent to, we have said, the weight of the man plus the weight of the ladder. So the weight of the man is 686 plus the weight of the ladder is 137.2. So all this is the Newton. This should be equal to, we have when we add, we are going to get 823.2 137.2. It is 823.2. So this is the normal force. Then from there we find the summation of forces in the x is equal to 0. Which forces are they? So remember, we have the frictional force, we have the force on the wall, which is going to give us the force on the wall minus the frictional force is equal to 0. That means if this goes this side, it will be, the force should be equal to Fs. And we know to say the Fs is equal to mu s times the normal force. We know to say the coefficient of static friction, is it the one we have been taught to find? Certainly not. So we have the calculate mu s, we found it's tan of 20. Mu s, according to this, they can climb between the ladder and the floor. Okay, they calculate how high up the man. If the coefficient of static friction between the ladder and the man is tan of 20, and tan of 20 was found to be 0. We found it to be 0. What did we find as our answer? Tan of 20 was 0.364. So we are going to find it by using that value. So we have 0.364, like that, times the normal force. And remember, our normal force is found to be 823.2. this is going to give us a value that is equivalent to, so 0.364. This is going to give us a value that is equivalent to this value for the normal force or the frictional force. Remember, the force on the wall is equal to the frictional force. In this case, it is equal to 299.62 newtons, like that. Then, with that said, we are going to have now we are going to go to our torques. So our summation of our torques, it is the one that is going to give us the distance, is equal to, we are going to say 0, like that. So now let's break it down. So we have the person. We don't know where the person is, so we have the weight of the person, we have the midpoint. Since they haven't told us, we are going to assume that it's uniform, so the weight of the ladder, like that. Then we are going to have the weight of the ladder, like that. So the weight of let's begin on the wall. So we have the force on the wall, and we have found this angle to be 49.98 degrees. So we have the force on the wall times the distance. So from here up to here, we have been told that this is 15 meters. So we are going to say 15. Then 15, remember the opposite side, it shall attract the sign there. So we are going to have the sign of our 49.98, like that. Oh, sorry, we found, is it 49? No, what value did we find here? 40.02. Where did I get the 49? It was for the wall. So be careful. So we have we found it to be 40.02. So remember our x here, we are using this, not this angle, we are using this angle, which is our 40.02 newtons, like that. So with that said, we are going to have our, so here it's supposed to be, I made a mistake, so it's 40.02, like that. So we are going to have our 40.02, like that. Then we have minus the weight of the ladder. The weight of the ladder, we have found it to be 137.2. Let me first just write algebraically everything. So we have the weight of the ladder, then the weight of the ladder times, so it's uniform. So at the center of 15, if the ladder is 15, the center will be 7.5. Then we have times the sine of, sorry, we are going to use the cos of our 40.02 minus the weight of the person times, we don't know the distance, so we are going to say x times the cos of 40.02. You should now know how to identify the angles. Now the force on the wall, we found the force on the wall to be 299. So we are going to have our 299.62 times our 15 sine of our 40.02. Then we have minus the weight of the ladder, which is our 137.2. Then we have times 7.5 cos of our 40.02. Then we have minus another one, which is minus our weight of the person, which is our 686. Yeah, so should be our 686 times our x cosine of our 40.02. This should be equal to 0. Let's just add them up. So let's just calculate now. So we want this x, So we are going to have our 299.62 times our 15 sine of our 40.02. This is going to give us a value of a 2890.14. Then we have our 137.2 times 7.5 times the cosine of 40.02. This is going to give us a value that is equivalent to, we have our 788.03 minus, we have our 886 times the cosine of our 40.02. This is going to give us a value of 525.35. Then it's attached with x, so at the end we have to write should be equal to 0. So we are going to have, let's simplify this. So when we subtract those two, when we have 2890.14 minus our 788.03, we are going to get a value of 2102.11. Then we have minus, we have our 525.35. X should be equal to 0. Let's take this value the other side. It will be 2102. It's remaining there, should be equal to, we have a 525.35 x like that. We divide 525.35, we divide 525.35. This is going to give us our x should be equal to 525.35. When we divide our value there, we are going to have our 4.001, which is just 4 meters like that. So that is how we go about those questions. So if you want more excellent content like this, kindly like, subscribe and share for more. And also see you in the next tutorial.